everyone to the lecture 16 of week 6 of this course, Climate Change and Extreme Events. In the previous lectures, we have already talked about what is exactly temporal, how do we perform, let us say, temporal analysis in the data set. We have also talked about several different types of analysis which can tell you about whether climate is the major responsible factor or human induced perturbation are the major important factors. We have talked about attributional studies. We have also talked about different types of statistical measures. For example, we can talk about we can apply breakpoint analysis, we can apply trend analysis, we can apply moving averages, we can apply frequency analysis, we can convert our data set into frequency domain, and then we can apply some sort of very advanced tools in frequency domain analysis, or we can break our data into multiple pieces and then we can try to look at which factor is actually causing the non-stationary behavior in the data set. So, these all sort of things which we have already covered, and these everything whatever we have covered so far in lecture 15 and previous lectures, that's essentially tells you about what is the hazard, what is the magnitude of any extreme events hazard, particularly if you talk about extreme rainfall or floods or droughts or tropical cyclone or other weather related extreme climatic conditions. We are essentially calculating what is the magnitude which has been changed over the past years and how it is basically behaving let us say in the future conditions also. So, we are essentially talking about only the magnitude which is somehow related to the hazard index of or hazard level of different extreme disaster in certain regions like that. But beyond hazard, there is a much more many concepts which are also important. For example, what are their risks if let us say similar magnitude of events are happening at two places, where in one places we have very prone to populations which are living and we have very exposed to that particular disaster, and there is one another region where we have a slightly higher magnitude of events are occurring, but the population density or exposure towards that events are not that really high if you compare to the first city or first region example like that. So, in that sense, risk is also a very important measure when you are talking about hazard of certain or hazard level of certain extreme events. It is also essential to evaluate what is their risk and how these peoples which are living close to that, let us say cities or districts or regions, are exposed to that particular type of climate disasters. That is what we will discuss about all these concepts in lecture 16. So, in this particular lecture we primarily look into it. We have talked about multiple times hazard identifications using several statistical measures. Then we will talk about risk analysis, risk evaluation, how do we control or manage the risk which are originated because of multiple climate disasters, how do we monitor and review, which is very important. Let us say if we are applying some sort of risk mitigation or adaptation measures, how do we monitor whether the policies or the frameworks or the disaster risk reduction approaches which we are applying, is it working based on the changing climatic conditions or anthropogenic responses, or we need some sort of more advanced techniques, which is also very important. Then the communication and consultation, whatever we have observed conditions for the real scenario, whether we are able to communicate the risk preparedness so that we can have a better adaptation and mitigation plan for certain climate disasters like that. So, this is what we will talk about in this particular lecture. So, overall in this lecture we will primarily focus on what is exactly risk assessment in the context of extreme events. We will explore key frameworks for assessing the climate related risks. We will learn about hazard, vulnerability and exposure analysis and what is the differences, and we will also look into it some sort of case studies where the risk assessment framework have been applied and they have got some sort of very interesting results. So, what is exactly risk assessment? How do we define it? So, risk assessment is the process of identifying, analyzing and evaluating potential risks or adverse effect that could result from extreme events or hazards. That is the definition. It involves systematically assessing both the likelihood of an event happening and the potential impact it could have in order to inform decision making and implement effective strategies to minimize or manage those risks. So, this is the formal definition of risk, where we have multiple layer of analysis involved. For example, first process is called hazard assessment, whether we have to identify the potential hazard and what is the magnitude of hazards based on several type of statistical test, time series analysis, data analysis, process based modeling, like that. Then when we evaluate the extent of exposure, let us say how many people are affected by a certain disaster, or if a certain disaster is occurring in a area where population density is very low, what is the their exposure, right. Let us say in certain region where the building quality is not that appropriate related to any kind of climate disaster, therefore their exposure is relatively higher. Then after this assessment, we determine what would be the vulnerability level in those region, and once we develop these vulnerabilities, we basically calculate what is the risk or likelihood or severity conditions or risk quantification in that particular region. So, hazard, you can understand that, let us say let us say if you take an example of flood, there are several written magnitude floods will occur in a certain region. Okay. So, 100-year return period is very high magnitude flood. Okay. So, let us say comparing 2, 3, 4 different locations, and based on that magnitude we identified 2, 3 or any particular locations are basically highly vulnerable or highly hazard prone for flood disaster. Then we analyze that how many people or what kind of settlements are there, what kind of their building materials are there, how many roads are very close to the flood affected region, or let us say is there any kind of electricity supply system or some sort of another services which are there which can be exposed to that particular process, or if any particular hazard will occur. Then we club it together, hazard and exposure together, and to find out what is the vulnerabilities there. So, suppose 100-year magnitude floods will occur there, and what would be the how many areas it will be affected, how many area will be basically affected by a particular types of flood disaster. Once we assess the vulnerability, we basically multiply vulnerability, exposure and hazard with together, that will give you a risk quantification of a certain region. It can be understand, we can further define it here. Hazard is basically you can talk about multiple different hazards, for example flood, drought, tsunami, storm, heat waves and all. And then vulnerability is basically depends upon the social system, physical or economic conditions there. Exposure is basically what kind of people are living there, buildings, environmental, infrastructure conditions there, and when all we integrate together, that basically called the risk of a particular disaster in that particular region. So, to quantify the risk, various framework has been developed. I will list down 3 important framework. For example, IPCC risk framework, where risk is quantified by multiplying the hazard, hazard level, hazard magnitude, then exposure and then vulnerability. So, this is basically when we have all these values, when we multiply with each other, and then we can compare which area has the higher risk or lower risk, like that, or it is possible that certain region has a higher hazard level, but because of the low exposure or vulnerability, those region has a high lower risk conditions. On the other hand, if a certain region where we have a lower level of hazard level, but exposure and vulnerability is very high, in that condition we have a very higher risk or extreme event risk in those locations, like that. When we have to use the climate adaptation planning to assess the risk proposed by climate related hazards, then we have to basically use this particular index. IPCC framework focuses on the understanding and interaction between hazard, particularly storms and heat waves exposure, and population infrastructure, and for vulnerability they are talking about the socioeconomic factors and resilience. Then another framework is called Sendai framework for disaster risk reduction, DRR, which emphasizes the resilience of buildings or infrastructural or critical infrastructures there. So, they are looking at those urban settlements, urban areas where we have a critical infrastructures which are susceptible to extreme disasters. So, what was their aim? It is to basically reduce the disaster risk and enhance resilience by focusing on prevention, preparedness and response strategies. So, this particular method is adopted by UN member states in 2015. It focuses on the proactive risk reduction, promoting disaster preparedness and enhancing early warning systems. It also encourages collaborative between governments, business and civil societies like that. Then another index is called ISO 31000 risk management standard, which focus on the risk identification and mitigation. It provides an internationally recognized guidelines for managing risk in organization. So, ISO 31000 is comprehensive framework for managing all type of risk from operational to strategic risk. The goal is to ensure that organizations are prepared for both threats and opportunities, helping them manage uncertainty and make informed decisions. So, it is also applicable to any organization regardless of size or industries. So, these are the three frameworks which basically can give us an information about the risk level of different disasters. So, what is the the first step to quantify the risk is to hazard assessment. Hazard assessment is basically potential impact, effect of system and communities, what is their intensity and frequency and duration, hazard characteristics, hazard and then hazard assessment, which is basically core processes of identification and evaluation of the hazards overall. That is basically called hazard assessment process, which can be included in what kind of the hazards which we can include is primarily, let us say, meteorological hazard, storms, heat waves and droughts. There are geophysical hazards, and there is a basically hydrological hazards which can be floods, droughts and landslide, can also be linked when we are talking about hazards magnitude or hazards assessment in a particular region. What are the methods? So, let us say if you identify one particular types of hazards, we have to perform the climate statistical analysis based on the data, or some sort of climate model projection or historical model data analysis or the climate analysis. We try to find out the trend, what is their historical behavior and what would likely to happen in near future scenarios like that. Then we calculate the probabilities and then we establish the or estimate the return periods with return magnitudes. On the other hand, climate model projections basically try to mimic the historical process based understanding and then generate the various different parameters or variables, for example, rainfall, temperature, floods, droughts, etc. Then we can basically project for future patterns, what is happening, what is likely to happen in future conditions under different scenarios. Once we establish this fact, we can basically assess the increased risk in different parts of the world like that. So, this is how basically the hazard can be assessed through these different methods. Then another term is called exposure analysis, because exposure is very important when we are looking at the risk at a particular locations. So, it is the major goal is to identify those which are at risk according to different hazard level, assessment of vulnerabilities, determine potential needs and developing the intervention strategies. So, this is the overall goal for a particular exposure analysis. How do we analyze the exposures? For example, we can use the census data, population data, we can use the GIS tools, we can look at the urban settlement or land use land cover change or something like that. We can use the remote sensing data set and GIS data set integrated to monitor which area has been significantly altered by, let us say, urban settlements, and where we have a higher intensity rainfall is very frequent, therefore, it can combine together and make it urban flooding kind of a problem there. So, this is basically exposure analysis process, where we basically look at different types of data set and tools for this kind of exposure analysis. For example, we talk about population density, we can talk about income level, we can talk about, let us say, different types of crop productions, we can talk about, let us say, multiple critical critical infrastructures, and what material they have used to build that particular structures like that, which is also sort of exposure when any particular disaster will occur. Or let us say, using the remote sensing in GIS dataset, we can also identify those locations where it is basically constructed near to the river channel or within the floodplains, where the floods are frequently occurring, and therefore those infrastructures might be in serious conditions if any high level flood events occurs there. How do we risk factor in hazard exposure? What kind of the factors which can be very important? For example, when we are talking about hazard, population density is one of the keywords, important terminology, which basically tells high density areas are prioritized in exposure analysis. Then we have infrastructure vulnerability, critical infrastructure is at risk for extreme events. Then we are talking about the ecosystem impacts, ecosystem effects, community resilience during the hazards. Then we talk about the service disruptions. What kind of the important services which will be disrupted if any particular extreme hazard event will occur. For example, if you talk about during the floods condition, it might possible that the electricity supply services will be disrupted, which might create further disaster. Or let us say communication services might be affected, which might not, we will not be able to utilize the communication services, and therefore cannot propagate our message from one place to the another place. Or let us say during the flood conditions, it might possible that the fresh water availability will be a little bit challenge, that might create some sort of service disruptions and can add the or can enhance the already hazard level in that particular certain regions. So that is basically also very important to understand when we are talking about hazard. Then there is another concept is called vulnerability assessment. Vulnerability assessment is basically, it refers to the susceptibility of various sectors. It could be communities, ecosystem and infrastructure to extreme events. It is essentially measures how likely they are to suffer or harm or disrupt during these events based on the various factors. For example, they are talking about physical vulnerability, where we are focusing on the availability of infrastructure to withstand extreme events. Then we are talking about social vulnerability, where we are talking about the emphasize the challenges faced by marginalized group in society, for example. Then we talk about economic vulnerability, which highlights the financial capacity to recover from the disasters. It depends upon different strata level in societies like that. Then we talk about the environmental vulnerability, which concerns the resilience of ecosystems against the disturbances. So combine all these different types of vulnerabilities, we can assess the integrated or joint vulnerabilities associated with different types of events in a particular regions like that. What is the vulnerability indicator? It is basically the socio-economic status, how we can measure the economic standing and its impact on vulnerability like that. Then we talk about the infrastructure resilience, assess the availability of infrastructure to withstand events during a particular climate disasters. Then we also talk about the emergency preparedness. So are we able to recover from a certain disasters if a certain magnitude of flood event or drought event or any climate disaster will occur in particular region? What is our emergency preparedness? How we can restore the essential services or supply the foods or migrate or relocate the people from one location to the another locations like that. Based on this understanding, we develop the vulnerability index, which is typically made of several indicators, that is social, physical, economic or environmental, and based on all these integration we can assess what is their vulnerability level at different places based on the different types of data set. So before moving this particular quantifying risk, I would like to add here. So for example, when you are talking about these different types of data set, this data set can be your point data set or can be your GIS data set also. So, point data set are those data set. Let us say if you go to the field and you collect the information through interview or one-to-one interview with the people, local people. You talk about, let us say, what is their income level, what is their let us say status of the agricultural land. You can also talk about frequent the disasters which are coming. Let us say how frequent drought events are coming. So these kinds of the data sets you collect from the field only, the point data set or primary data set. There is a secondary data which is also called, which is collected from the GIS or secondary sources. Not directly go to the field, but you collect the data from secondary sources. It could be your census data, which is collected by some third person and given the access to you, and then you can explore the data set. Or let us say you can use the GIS data, for example. You can use the GIS data and then you can figure it out which area has been significantly changed the urban cover, or deforestation is very high, or people are now living very close to the river channel, or people are living where we have a low availability of water, or like that. So these kind of the information we collect from the remote sensing or secondary sources and integrate. So therefore, when you are quantifying the vulnerabilities, quantifying the exposure, quantifying the risk, these data sets plays a very critical role, and based on your the hazard data set, this will basically add or complete the whole story of a certain regions, like that. Okay. So, the quantifying the risk, how do we quantify risk? Basically, we expect the annual losses, what is the, and then we basically calculate the return periods of different hazards. Then we basically calculate the time between events, inter arrival period, and then we basically also apply infrastructure resilience and emergency plans, like that. And then we also apply some sort of probability potential losses when we are talking about different types of losses. It could be your agricultural, social, or economical losses, and then we basically determine the financial risk at certain places. So this is how basically we can establish the risk matrix at a particular locations. What are those softwares? You can directly use time series analysis software, plus if you have the time series data set, you can club it together and then you can do that analysis in different programming languages. Or you can, if you have, let us say, spatial data set, you can also integrate all these data set in QGIS, RGIS kind of GIS softwares, and you can make a layer data set, stacked layer, and then you can identify which region has higher risk or vulnerabilities there. Or maybe you can use some sort of dedicated softwares like these, where you can basically perform the disaster risk assessment or climate related risk assessment, or then you can talk about emergency plans or some sort of insurance schemes, so that we can recover or we can support if somebody has been affected by different types of hazard levels. Then we can also talk about different types of adaptation strategies, so that we can adopt for the future conditions if certain things are happening. And then we can also try to look at the cost effectiveness of analysis, where we are talking about if we have multiple approaches, alternative adaptation strategies, we can compare it together, and then we can talk about which strategies will give you better cost effective or balance between low cost or let us say higher mitigation strategies, like that. So that is basically we can also do using these softwares, and then we can propose a certain strategies which might helpful for lowering down the hazard in a certain region. So these are the some of the case studies where this particular region, South Asian region, where floodings is the very frequent problem, and therefore we need to understand about how these regions are basically categorized for the different flood events. So they people have done this analysis for different years, and they have tried to classified all these regions based on their risk level. For example, the several regions like this, Indonesia and all, are affected by a very high risk indicator, where if the flood will occur, they basically disrupt the whole populations or very major proportion of the populations, and therefore affect the socioeconomic condition in that particular region. Similarly, they have replicated this analysis for 2005, 2010 and 2015, and try to calculate what is the flood disaster risk at different regions. For example, Cambodia, Myanmar and Philippines, Singapore and Thailand are medium risk. They have quantified Laos and Malaysia for low flood, and Brunei as extremely low flood index. So, similarly, this kind of analysis can be replicated in your regions also. Let us say various district level or village level in India or in different states, and try to look at which region has extremely high vulnerability or risk, or extremely low risk, like that. So, this is another example where we are talking about the heat wave hazard index in the Europe, and we are talking about multiple stations where people have done this analysis to categorize which region has the highest or very high severity or risk associated with the heat wave hazard. So, basically they have calculated multiple places, Central Europe and these areas where we have a very high or high of hazard index based on changing historical conditions, like that. So, they have used several heat wave hazard index, for example, number of heat waves, a number of long heat waves, a number of high intensity heat waves, or timing of the first simultaneously long and high intensity heat waves together to calculate the overall index of these particular regions. So, this case studies tells you about, let us say you have a certain disasters which are happening in a geographical locations. You can calculate the hazard magnitude with overlapping with your socioeconomic or let us say sociological information there, and you can club it together and you can find out what would be the region which is highest in the risk or vulnerability assessment. So, this can be a very essential tool to basically quantify the geographical locations where we have the highest vulnerability or risk assessment, like that. Then another or final step of risk quantification is risk communications. So, you have quantified the risk, but you have to communicate with the the lower or let us say multiple layers of the people. How do we do that? Basically, let us say you have identified the risk, you use some sort of risk matrices, and then you identified a certain the climate risk is climate disaster or climate hazard is high risk conditions or low risk conditions. When you categorize this, then you basically try to look at their probabilities or their magnitudes, like that, and then we try to implement some sort of decision support or simulate different scenarios or different evaluate strategies to mitigate that types of risk, and then you try to communicate these whatever you got the results, you communicate with the people, local people, or let us say local government or the central governments, like that, so that they can manage or they can implement some sort of policies to reduce the risk exposure to that certain regions. How do we do that? We basically try to look at the data set, we break down this complex data set into simpler form, then we create some sort of understanding formats, then we calculate the probability and magnitudes, then we calculate what is their potential impact or risk levels, and then we try to based on the risk level and magnitude level and probability assessment, we try to look at what would be the mitigation strategies or their costs, so that we can manage it for different conditions. So, how do we communicate this risk? We can develop the early warning systems, which is that provides a timely alerts for extreme events. For example, if you talk about cyclone early warning system developed by IMD, which basically can precisely locate what would be the path of the cyclone in different parts of the Odisha or Bengal or all these coastal regions. Then meteorological data set, which we can also predict which districts or village or regions are going to experience a very extreme rainfall events, so that we can prepare for some sort of urban flooding or flooding kind of disaster in there. So how do we communicate? We can send various these messages through various channels, maybe mobile phone or some sort of emails or some sort of other, or televisions or some sort of other devices where we can disseminate this information to the local people. Then we have also satellite imagery analysis. We basically analyze the images in a certain region and try to find out what is the overall the dynamics of cloud and how the monsoon is behaving, for example, and what is the extent of, for example, let us say forest fire or because of the heat waves. So, this is kind of the information we can collect using the satellite imageries. Then we have also environmental sensors, which basically continuously measures the different properties of environment in particular location. We have the climate models, which we have already discussed in the previous lectures, that we can identify the higher risk region based on the certain different projections level or greenhouse gases emission levels, and then based on all these information we can calculate the risk of a particular region, what would be their categories for risk. So, this is a simple example where people have developed a risk communication dashboard based on the different surface water and groundwater availability, and they can find out let us say flood warning alerts. They can tell you okay, which area is going to experience a flood in let us say past a few days, like that. So, this is one of the ways we can communicate whatever the findings or risk assessment to the local people, local government, so that they can have a better management plan and they can minimize the consequences of these extreme events, like that. Then the adaptation and measures, which is basically a very important because when we are talking about adaptation and mitigations, we are essentially talking about short term and long term management of these different extreme events. We talk about the flood resilient structures, coastal defense, robust energy grids, water storage system, meteorological warming system or early warning system, like that. When we are talking about the mitigation measures, we talk about the transitional renewable energy, or we talk about the energy efficiencies or some sort of land use, land cover planning, like that, so that we can manage these risks in the future conditions, like that. So, in this particular lecture, we have primarily talked about the risk assessment, we have talked about the integrated hazard, exposure and vulnerability analysis part wise. We have also talked about different types of frameworks, for example, IPCC, Sendai and ISO 31000. How do we apply, or basically what are their major points for risk management. And then we have also talked about quantifying risk support informed decision making based on multiple risk quantifications, or integrating different types of data set, or communicating the risk results to the local people or local government, so that they can have better management plan for any particular climate disaster in a certain regions, like that. So, in the next lecture, we will primarily talk about how do we calculate the return periods of rare events. It is very important criteria, because when we are defining the risk of a particular region, it's very important properties for understand about, let us say, what is their hazard level in a certain regions. Okay. Thank you so much for your attention.